The essential question is, for this video, how do we use coordinates to find the circumcenter? But there's a couple things we need to know before we can do that. And the first thing is, what's the relationship between the slope for perpendicular lines? So for example, let's say if this line right here had a slope of, let's say 3 over 2. Okay, so rise over run up 3 over 2. If this is a perpendicular line, we know what the slope of this line is going to be. It's going to be negative 2 over 3. So look how these slopes compare to each other. One is positive, one's negative. That makes sense because from left to right, this line is going uphill. That's going to be a positive slope. If you have one line going uphill, a perpendicular line will always be going downhill. So if you have a pair of perpendicular lines, one will always be positive and the other one will be negative. So they will always be opposite in sign. But also you see what's happening with the fraction. 3 over 2, 2 over 3. They are reciprocal. So perpendicular lines will always have slopes that are two things. Opposite and reciprocal. Okay, that's what happens when you have perpendicular lines. Opposite meaning opposite in sign, and reciprocal. Okay, so keeping that in mind, let's say this positive line had a slope of 4. What would be the slope of a perpendicular line? Say it out loud. I'm hoping that you said negative 1/4, because the number 4 is equivalent to 4 over 1. And of course the reciprocal of 4 over 1 would be 1 over 4. And of course it has to be opposite in sign, so that one's positive, that one's negative. Okay, let's do one more. Let's say the slope of this line was negative 3. What would be the slope of this line? That would be positive 1/3. Okay, did I say one more? Let's do one more. What if the slope of this line was negative 1/5? What would be the slope of a perpendicular line? A perpendicular line would have a slope of positive 5. Okay, the reciprocal of 1/5 is 5 over 1, and of course we won't leave the 1, we'll just put 5, and then we have to do the opposite sign. One more. I keep saying that and I keep making myself a liar. What if one line had a slope of 1? Just positive 1. What would be the slope of the other line? It would be negative 1. What's happening here is a slope of positive 1, if I wanted to sort of look at it as a fraction, that's like having 1 over 1. Well, the reciprocal of, if I want to go perpendicular, the reciprocal of 1 over 1 is still 1 over 1. Okay, it's getting in the way now. Alright, the reciprocal of 1 over 1 is still 1 over 1. But of course we have to change the sign and make it negative. Okay, and negative 1 over 1 is just negative 1. Okay, so that's something that you had to have in the back of your mind to be able to deal with circumcenter. Now why? What are these slopes and perpendicular lines? What do these things have to do with circumcenter? So part of the deal is, what is circumcenter? What's the definition of circumcenter? Well, all of our triangle centers are, the intersection of some kind of line. So in the case of circumcenter, what are the three intersecting lines that will locate the circumcenter for us? Did you figure it out? The circumcenter is the intersection of perpendicular bisectors. Okay? And this is the reason why we just spent a couple minutes talking about perpendicular. And we looked at the slopes of perpendicular lines because circumcenter will involve perpendicular bisectors. Remember, perpendicular forms 90 degrees. Bisectors are going to cut a segment in half. So, just in general, say if I've got some kind of triangle, if I want to locate the circumcenter of this triangle, I need to build at least two perpendicular bisectors. Let's start with the perpendicular bisector of this side. See, each side is going to have a perpendicular bisector. So this would work better on graph paper, which is coming, but if it's going to be a bisector, I need a segment that's going to cut this side in half. So let's imagine that this is the midpoint right here. So all I need is a perpendicular line that goes through that midpoint. Okay, if this is the midpoint, that means these should be congruent. So if I draw a perpendicular line right now, then that should be the perpendicular bisector. Okay, so if I draw something like this, all right, that line I just drew, that would be one of my perpendicular bisectors. Okay, if I have another perpendicular bisector, wherever they intersect should be the circumcenter. So let's look at this side, for example. And I'm just eyeballing it. I'm not measuring with a ruler or anything, but let's say this is about the median. I mean the midpoint of this side of the triangle. So if I get a perpendicular line happening, okay, something about like that seems perpendicular to me. Okay, so this would be another perpendicular bisector. Again, that's assuming that I correctly identified the midpoint of this side over here. All right, but if that's the midpoint and this is about perpendicular, then where these points meet should be the circumcenter. Okay. Now I'm feeling I'm a little off. But anyway, and I could do the same thing again. Let's say if this is the midpoint, if I did another perpendicular line, okay, and I'm betting that that should have been a little bit more like this. Okay, the place where these three lines meet would be the circumcenter. So in this case, this spot right here would be the circumcenter. Okay, so it's all about constructing at least two, possibly three perpendicular bisectors. And wherever they meet, that's going to be the circumcenter. Now, let's see how that's going to look on graph paper. How will that look if we have coordinates? So here we are on graph paper. If I want to find the circumcenter of this triangle, again, I need to create at least 2 perpendicular bisectors. So here we go. Let's start with this horizontal side because that'll be the easiest. If it's going to be the bisector, it's going to have to hit the middle of this side. So this side is 10 long, so the middle will be exactly 5 over. So there's 3, 4, 5. So I don't have to guess. That's the benefit of doing the graph paper. I can count these squares and be exactly at the middle. So all I need to do is go perpendicular, and the graph even shows me where the perpendicular is going to be. So we can just be a lot more precise when we do our perpendicular bisector. So this would be a perpendicular. Okay, so that line is a perpendicular bisector. Alright, so there's one perpendicular bisector. Yeah, I'll go ahead and just put a little box here to remind us that that is perpendicular. Okay, so all we need really is one more perpendicular bisector, and that will show us wherever they meet, that's going to be the circumcenter. So it really doesn't matter which one of these sides I'm going to use. I think I'll wind up doing both sides just to, just for practice, to show you guys how it's done. Okay, so look at this. If I want to do the midpoint of this side over here, it's not hard to see where the midpoint's going to be. Even though I can't really just count the squares exactly, I can tell the midpoint's going to be right here. And I'm kind of looking at slope when I do this. See how, looking at this point, see how it's down to over 4? And then to get to the other end, I would go down to over 4. So because it's that same pattern, down to over 4, down to over 4 the rest of the way, that guarantees me that this will be the midpoint. Okay? So now all I need to do is perpendicular. Now, as I was doing that, the slope, so, okay, this is important. The slope of this side of the line, okay? I said down 2 over 4, okay? So that's negative 2 over 4. But what does that reduce to? 1/2. So in fact, let me just replace that. So down 2 over 4 is the same thing as negative 1/2. And if you think about it, I could have looked at it this way. Down 1 over 2, down 1 over 2, 1 over 2, 1 over 2. So you see the slope of this line, the rise and the run, is down 1 over 2, so negative 1/2. Now, like we practiced earlier, what will be the slope of a perpendicular line? Because this is going to be important. Say it out loud. I'm hoping you were at least thinking that the slope of a perpendicular line is going to be positive 2. The reciprocal, remember, it has to be opposite and reciprocal. Okay? If this one's negative, the other one's got to be positive. If this is 1 over 2, this one's got to be 2 over 1, which is 2. So, as I draw my perpendicular bisector, I've already put the midpoint, so I know it's going to be the bisector. But to make sure that it's perpendicular, I need to make sure that the slope is 2. And I will go ahead and say 2 over 1 to remind us that rise over run, this line I'm about to draw on needs to have a slope of up 2 over 1. So if I were you, I would start drawing the line from this midpoint. So using the slope up 2 over 1, up 2 over 1 would be like this, up 2 over 1. I could continue the pattern in the other direction by going down 2, back 1, down 2, back 1. Okay, down 2, back 1, down 2, back 1. So you can see already where those lines intersected. They meet right here at the point 3, 0. I'm going to go ahead and draw the line. Okay, so this purple line is another perpendicular bisector. All right, it's perpendicular right here, and it's a bisector, it's the midpoint. So we've answered the question already. We found if I was looking for the circumcenter, I found it. So the circumcenter is alright, so the coordinates of the circumcenter would be, in this case, 3, 0. Okay, it's right there. Okay, now just to be thorough and for extra practice, let's go ahead and see what the other perpendicular bisector would look like. It's just good practice. Okay, I will go ahead and use green this time. Okay, so looking at the final side that I haven't used yet, I'm hoping you can see that the midpoint of this side would be right here. Now let's go back and talk about slope and everything again. Maybe I'll leave that opposite and reciprocal. Okay, so one more time, the slope. Okay, looking at this line over here, the slope is up to over 1. Okay, up to over 1. So the slope is 2. All right, and I could think of it as 2 over 1. So what will be the slope of a perpendicular line? A perpendicular line will have slope negative 1/2, opposite in sign and reciprocal, 2 over 1, 1 over 2. So again, because I've placed the midpoint, I know I'm going to have a bisector when I draw this line. To make sure that it's perpendicular, I have to make sure I do a slope of negative 1/2. That's down 1, right 2. Down 1, right 2. In fact, when you do a negative slope, you can think of it this way. Put the negative sign always in the numerator. So that's down 1, right 2. So from here, I will go down 1, right 2. 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 I could continue the process to the left by going up 1, back 2, up 1, back 2. So you see these green dots are showing me where my new perpendicular bisector will be, my third perpendicular bisector. Once again, of course, it's still hitting the same point. The circumcenter is 3, 0. I just wanted to show you one more time how to draw a perpendicular bisector. I'm going to go ahead and draw it in. Okay, so that is my final perpendicular bisector. It's perpendicular right here, and it's the midpoint of this side. So it's a perpendicular bisector. And that's how you do it. That's how you find the perpendicular bisector, and you use those to find your circumcenter. I'm going to do one more example, but it's just going to be a repetition of the same thing. So if you feel like you understand, you can stop watching now. Okay, let's do one more example using this triangle right here. Alright, remember, our goal is to find the circumcenter. What are the coordinates of the circumcenter? That's a question that we're trying to answer. And of course, we know that a circumcenter is the intersection of perpendicular bisectors. So we are going to draw at least 2 perpendicular bisectors, and that will show us where the circumcenter is. So the easiest perpendicular bisector to draw is going to be the one that goes with this vertical line. So the midpoint of the vertical side here, let's see, 1, 2, 3, 4, 5, 6. This is 6 tall, so that means the midpoint is going to be right here. So if I draw a perpendicular line here, that'll be a bisector And if, of course, if it's perpendicular, it'll be a perpendicular bisector. Of course, this is easy because a perpendicular line, if this is vertical, a perpendicular line will just be horizontal. So all I need to do is draw a horizontal line right here, and that will be my first perpendicular bisector. Okay, that's really long, but that is my first perpendicular bisector. Okay, I'll put a little box here to remind me that it's perpendicular, and it's the midpoint, so it's a bisector. Now, let's go ahead and draw another perpendicular bisector. You're just going to pick one of these other two sides. Doesn't really matter which. Again, I'm going to do both just for practice. Okay, say if I do this side up here. The midpoint is obviously right here. Up 1 over 2, up 1 over 2. This is in the middle. Now, speaking of up 1 over 2, perpendicular lines have slopes that are opposite and reciprocal. So let's talk slope. Okay, the original slope, like I just said, is up 1, right 2. So the original slope is 1/2, up 1, right 2. A perpendicular line will have slope what? Well, it's got to be opposite in sign, so if this one's positive, this one will be negative, and reciprocal. So instead of 1/2, it will be 2. Okay, and I'm going to go ahead and write 2 over 1 to remind us that when I do the slope, I will go down 2, right 1. So, as promised, so starting from my midpoint, I'm going to do this new slope, this perpendicular slope, down to right 1. So down to right 1 will put me right here. And I can already see where they intersect, but I will keep going. Down to right 1, down to right 1. I can go back to up 1. So you can already see, but based on the fact that this dot is on the first perpendicular bisector, I can already see what the circumcenter is going to be. It's going to be the point 7, 5. But let's go ahead and draw it. So here is my perpendicular bisector. Alright, that's my perpendicular bisector. So it was perpendicular to this side, and it was a midpoint, so it will be a bisector. So yes, the circumcenter is going to be the point 7, 5. Alright, but let's follow through and find our third and final perpendicular bisector. But if this was a test or something, you did 2 of them, you see where they meet, that's enough to be guaranteed that this is the circumcenter. So you don't have to do the third one. This is just really for practice. So we found the midpoint of this side and drew a perpendicular bisector. We found the midpoint of this side and we drew a perpendicular bisector. So there's only one side left that we haven't done yet, and that's this side. And you can probably see that the midpoint of this side is going to be right here. Alright, down 2 over 2, down 2 over 2, this is right in the middle. Now, you heard me saying down 2 over 2, so let's see. So let's talk slope. So the slope of this side, you heard me say down 2 over 2. But what would this reduce down to? Alright, hopefully you see that this would reduce down to down 1 over 1, or really just negative 1. So, what would be the slope of a perpendicular line? Well, the reciprocal of 1 over 1 is still 1 over 1. But since the first one was negative, a perpendicular line will be positive. So it'll be positive 1 over 1. All right? That's up 1, right 1. And of course, positive 1 over 1. Really, the slope is 1. Okay, that's what's really happening. Okay, but as far as graphing it, we'll look at these. So, starting from the midpoint, let's use the perpendicular slope and go up 1, right 1. So if I do that, I will go up 1, right 1. It's going to be right there. Up 1, right 1, up 1, right 1, up 1, right 1. I could put more points in this direction like so. Okay, so these green dots are showing you where my third and final perpendicular bisector will be. But let's go ahead and draw it in. Okay, so there's my third and final perpendicular bisector. Okay, when I say that this is a perpendicular bisector, I'm talking about the fact that it's perpendicular right here. It's perpendicular to the side. And it's a bisector of the side. You can see it's the midpoint. And as we knew it would, this green perpendicular bisector hit the same intersection point of the other two, the point 7, comma 5. So the circumcenter is in fact 7, comma 5. All right, and that's it. So hopefully now you understand how to find the circumcenter coordinates. You know, if you have graph paper, all you really have to do is draw 3 perpendicular bisectors. As far as making a bisector of each side, make sure you are using the midpoints of each side. As far as being perpendicular, use your slope. Find the slope of the side, and then go opposite in sign and reciprocal, and that will tell you the slope of your perpendicular bisector. And wherever they meet, that will be your circumcenter.